Good morning students. In this video we will discuss problems on 3D geometry, especially 3D lines. Yes. See question number 1. The value of k. Asked the value of k if this line, a line is given in the symmetric form, if this line lies on the plane. If the line lies on the plane, what is k value? Very simple. See, say this is the given plane. Yes. And a line is given that this line lies on the plane. What is this line? It is in symmetric form. Therefore, it passes through the point 4, 2, k, and which has drs 1, 1, 2. This is the question. This line lies on the plane. What is the equation of the plane? 2x minus 4y plus z is equal to 7. The line lies on the planes means the point 4, 2, k. It also lies on the plane. That's all. So the point, since the line lies on the plane, a point on the line, what is this? It is a point on the line. It also lies on the plane. Lies on the plane. 2x minus 4y plus z is equal to 7. Therefore, if a point lies on a curve, it has to satisfy. Substitute in this 8 k is equal to 7. I can cut minus 8 plus 8. So what is k value? K value is 7. Therefore, first option, yes. Next question, question number 2. If the line, again a line is given, this is the line. If the line lies on the plane, it lies on this plane. If the line lies on the plane, then what about alpha beta values? What are the values of alpha beta? Again same, here a plane is given, say this is the plane. The given line, it lies on this plane. What is this line? This line is given in the symmetric form. Therefore, a point on the line is 2, 1, minus 2. And drs of this line. What are the drs of this line? 3 minus 5, 2. And equation of the plane is given x plus 3y minus alpha z beta plus beta equal to 0. So we know xyz coefficients in the plane's equation, they will be representing drs of normal. What is normal? This perpendicular line is normal of the plane, whose drs of the normal are xyz coefficients. Therefore 1, 3, minus alpha. So here we need to find two values. First of all, the line is on the plane. Therefore, this point also lies on the plane. We will use that condition first. 2, 1, minus 2 lies on the plane. Which plane? Given plane. X plus 3y minus alpha z plus beta equal to 0. A point lies on a plane. That means it has to satisfy. Substitute in this. 2 plus 3 minus into minus plus 2 alpha plus beta equal to 0. We obtained an equation. Since it is objective, after getting one equation, you can verify the options. If you get only one option satisfying this, that self is answer. Okay. Nextly, we will see what are these numbers. They are drs of the given line which is on the plane. And what about this? This is normals drs. This normal is perpendicular to plane. That means it is also perpendicular to line. Therefore, if two lines are perpendicular, they will satisfy this condition. A1 A2 plus B1 B2 plus C1 C2 equal to 0. These are drs of normal, drs of line, they are perpendicular. A1 A2 is 3, B1 B2 is minus 15, C1 C2 is minus 2 alpha equals to 0. Write 2 alpha on right side, it becomes plus. What will be there on the left side? Minus 12. This implies what is alpha? Alpha is minus 6. Therefore, alpha value is minus 6. In objective, you should watch options for all the questions. First read the questions, then you see the options. You may get some idea. So alpha is minus 6. There is only one option containing this. Therefore, no need to find beta. This is the answer. So we will find here, no problem. Alpha is minus 6. No, we will put here. 2 plus 3 is 5. Alpha is minus 6. That is 12. Beta equal to 0. 5 minus 12 minus 7. No. Therefore, beta equal to 7. Therefore, the values of alpha comma beta are minus 6 comma 7. C. Second option. Next question, question number 3. The symmetric form of the line. This line, you please see here, line is given in the form of planes. We know that two planes together they decide a line. So this is first plane and this is the second plane. These two planes will decide a line. So common portion of two planes is a line. So therefore a line can be represented by two planes. Okay. So what he asked? Asked symmetric form of the line. What is symmetric form? See the options. These are symmetric forms. X minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. So to express a line in symmetric form, we need a point on the line and drs of its equation. Okay. So how you please watch the options. These are the options. In these forms, the denominators, they represent drs of the line and you can obtain point from the numerator. So you observe the options. So here there is no y coordinate, no z coordinate, no z coordinate, z coordinate is 0. So by watching options, you suppose any one is 0. So I will take z is equal to 0 because this is there in the three options. First option, z coordinate of what is point on this line? 5 comma 0 comma 0. This is 1 comma 5 comma 1. 3 comma minus 1 comma 0. Minus 5 comma 0 comma 0. You can take any one. I took z 0. If I will not get answer, then I will take other y equal to 0, etc. Yes. I suppose z is equal to 0. If I take z is equal to 0, the first plane becomes this. I put z is equal to 0 in this. I shall also put z is equal to 0 in the second plane. I obtained two equations. So we shall solve the equations. What we do? I will multiply this with 3. Not 3, we should multiply with 6 no, to make x coefficients or y coefficients equal. So if I multiply with 6, 12x, 6y, 6 5 is 30. By adding I can cut these two. 15x is equal to 45 implies x is equal to 3. By taking z is equal to 0, I obtained x value is 3. Write x value in this or this, you will get y value. If you write x equal to 3 here, this will be 6, no? If you write on right side, it becomes minus 1. So therefore the point has come. The point on the line is x value is 3, y coordinate minus 1, z coordinate 0. So to find a line in the symmetric form, we need a point and drs. Yes, we obtained a point. Since it is objective, I said always you watch the options. See, all the 4 options, they contain same denominators. That means drs of line 14 to 15, 14 to 15, 14 to 15. Now you no need to find those drs because all the options contain same. So by watching the point, you can pick the answer. What is the point? 3 minus 1, 0. It is not there in the first option, 5, 0, 0. Second option also, this is not there. Where is it? It is 3 comma minus 1 comma 0. Yes, therefore third option. So here in the options, all the denominators are same numbers. That means same drs. By only point we have picked the answer. All the times it may not possible. We will see the remaining procedure also. Yes. So if you take this figure, these are the 2 given planes. Yes, these are the 2 given planes. Their common portion is line. This is the line. So to find the line, we need a point. Already we obtained a point. Now we need drs of line. So I will suppose drs of the line A, B and C. So this is equation of first plane. In the equation of plane x, y, z coefficients, they always denote its drs normal. So for first one, what are the drs of normal? 3 comma minus 6 comma minus 2. For second line, its normals drs of its normal are 2 comma 1 comma minus 2. Listen carefully, it is a 3D figure. What is this line? It is a normal to the plane. It will be perpendicular to the plane. This line lies on this. It belongs to both. Since it lies on this normal line is perpendicular to plane. Therefore, it is also perpendicular to line. In figure, it may not be clear. This line also belongs to this plane. This line is normal to the plane. That means it is also perpendicular to line. So therefore what I want to say is this line which has drs ABC is perpendicular to both the normals. If they are perpendicular, they have to satisfy the condition A1, A2. B1, B2, C1, C2 equal to 0. So taking this and first one, if I apply this, I will get minus 3A minus 6B 2C equal to 0. This is also perpendicular to this, no? 2A plus B minus 2C equal to 0. There are 2 informations. We obtained 2 equations. We cannot find ABC exact values. Only proportionate values can be found. But since ABC are drs, proportionate values are enough. Let us find them. A divided by minus 6 minus 2 is 12. Minus 2 into 1 minus 2, minus into minus plus. While writing second one, write minus. 3 into minus 2, minus 6. Minus 2 into 2, minus 4. Minus into minus, plus 4. And we have C in the third one. 3 into 1, 3. minus 6 into 2 minus 12, which is plus 12. Therefore a divided by 14 minus b divided by minus 2, minus cancelled, c divided by 15. Therefore the drs of the line are 14, 2 and 15. These are the drs and this is the point. We have applied that symmetric form. X minus x1 by a means 14, y minus y1 by b is 2, z minus z1 0, by c is 15. That's all. Third option. Next question, we will see next question. The length of the perpendicular drawn from the point. The length of the perpendicular from the point 3 comma minus 1 comma 11 to the line, this line. So this question will be there in planes also. Perpendicular distance, length of the perpendicular to a point to a plane. There it is very simple. Just mod ax1 by1 plus cz1 plus d by root over a square plus b square. But here you please see. Say this is the given line and this point is given, no? So the point is 3 comma minus 1 comma 11. I will suppose this is A. The line and point are given. Line is given in the symmetric form. Therefore a point on the line is 0 comma 2 comma 3. So 0 comma 2 comma 3 is a point on the line. We don't know its position. So I will take here, what is this point? 0 comma 2 comma 3. What is asked here? Length of the perpendicular. Length of the perpendicular from the given point to this line. Say this is m. So here we need to find am value. Yes. So what I do, I can find this distance, no? Because I have these 2 points. I will find this length. Root over 3 minus 0, 3 square is 9. Minus 1 minus 2 minus 3 whole square is 9. 11 minus 3, 8 whole square is 64. Therefore what is this? This is root over 64 plus 18. What is this? 82. What is this in the figure? In the figure, this is AP distance. AP distance is root 82. We have to find AM, no? This is a right angle triangle. How to find AM square, AM distance? Using Pythagoras theorem. AM square can be AP square minus PM square. So this is already find AP. We need AM. Now it is enough if you find PM. What is PM? Very simple. PM is length of the projection of AP on this line. So to calculate this, from the equation of the line, what are the DRs of the line? DRs of the line 2 comma 3 comma 4. So what about their DCs? DCs will be 2 by a square plus b square plus c square root over 16, 20, 29. So by 29, 3 divided by root 29, 4 divided by root 29. Once again, we have to find this distance AM. We have already find AP. Now I will find PM. What is PM? PM is length of the projection of PA line on the given line. Therefore, we have a formula for that. PM is equal to L into x2 minus x1. DRs and DCs. y2 minus y1. We have seen this in DRs and DCs. Z2 minus Z1. This is projection of PA on the line where LMN are DCs. So what is L? Carefully, 2 divided by root 29. X2 minus X1, 3 minus 0 is 3. Next, what is M? These are LMN values, DCs. M is 3 divided by root 29. Y2 minus Y1, minus 1 minus 2 is minus 3. And N is what? 4 divided by root 29. Z2 minus Z1 is 11 minus 3 is 8. So I can take LCM. LCM is root 29. Here I will get 6 minus 9 plus 32. Yes. 32 plus 6, 38 minus 9, 29 divided by root 29. This implies this is root 29. What is this? This is PM. PM is what? Root 29. AP is there, PM is there. You can substitute here. What is AP square? It is 82 minus. This is PM, no? PM square is 29. 82 minus 29. What is this? This is 53. So AM square is 53. Therefore AM equal to root over 53. This is the answer. Therefore, fourth option. Yes. Perpendicular distance from a given point to a line. Next question. See Nana. Here, if the lines, two lines are given, these are the two lines which are given in symmetric form. This and this. These are the two lines, and given that they intersect, two lines intersect, then what is K value? I have told in the conceptual videos about coplanarity of 3D lines. The lines, if they are parallel or intersect, then they are coplanar. The lines which are neither parallel nor intersects or nor non-coplanar lines, such lines are skew lines. So here what is the concept? Very simple. Here given that lines are intersecting, or simply lines intersect. Lines intersect implies they are coplanar. They are coplanar. This concept is important. Whenever two lines are parallel or intersect, definitely they are coplanar. Coplanar means they will lie on same plane. For example, you suppose this is the plane on which the two lines lie. So here given that the two lines intersect, roughly this may be the figure. These are the two lines. They are intersecting. This is first line. You suppose this is second line. Now see. So both the lines are given in symmetric form. Therefore, I can find a point on first line. What is this point? It is 1, minus 1, 1. Also, I can find a point on second line. What is this point? 3, k, 0. These are 2 points on the two lines respectively. For first line, what are the DRs? For first line, DRs are 2, 3, 4. For second line, DRs are 1, 2, 1. Yes, now you please concentrate. Two lines are given that they intersect. If lines intersect, then they are coplanar. So if they are coplanar, where they will be like this, they will be lying on a plane. So these are DRs of first line. So I have taken reverse, no problem. This is the first line, no, whose DRs are 2, 3, 4, and the second line DRs are these. So this is first line. DRs means what? DRs of a line means in vector algebra nothing but a vector parallel to that line. So this is a vector. See, all these things lie in same plane. This is a vector. Another dr is there. This is also a vector. Two vectors are there in the plane. Now these are 2 points. Now if I join them, I will be getting another vector. So first vector, second vector, third vector. Now there are 3 vectors in this plane. Those 3 vectors lying on same plane, that means they are coplanar. If the 3 vectors are coplanar, then we have a condition det equal to 0, scalar triple product box equal to 0. So what is the first vector? It is obtained by joining this and this. Say this is A, this is B. AB bar is this vector, OB minus OA. I am writing that vector OB minus OA, 3 minus 1. Next K minus into minus plus 1. 0 minus 1 is minus 1. Another parallel vector given by dr or drs of one line. Another parallel vector. Another vector in the plane. These are the 3 vectors in the plane. Therefore, they are coplanar, scalar triple product is 0, that is box equal to 0. We shall expand this 2 into 8 minus 3. What is it? 5. Minus of k plus 1 into 4 minus 2 is 2. Next minus 1 into 3 minus 4 is minus 1 equal to 0. So if I expand this 10 minus 2k minus 2 minus into minus plus 1, I will write 2k on other side, it becomes plus. On the left side 10 plus 1 11, 11 minus 2 is 9. This implies what is k value? K value is 9 by 2. Therefore asked k value 9 by 2. Therefore answer is third option. Yes. Next question. See, if theta is the angle between the line, between this line and the plane. Here what is this? This is plane and this is line. Plane's equation is this. So there is a line here and a plane is there. Angle between a line and a plane. So we have seen angle between two lines. Cos theta equal to a1 a2 plus b1 b2 plus c1 c2 by root over a1 square plus b1 square plus c1 square into root over a2 square plus b2 square plus c2 square. If two planes are given, then also same. Angle between two planes is angle between their normals. Normals means they are also lines. So we have seen this in conceptual video. When a line and plane are given, how to find the angle? Same formula. Only instead of cos theta, sin theta will be there when line and plane are given. Yes. So you see the drs of line. Drs of given line are. From the equation, what are the drs? 1, 2, 2. Next, drs of normal of the plane. Drs of normal of the plane. Yes, In the equation of a plane, we know that x, y, z coefficients, they will be representing dr's of normal. So actually we have to find angle between line and plane, but we are considering normal instead of plane. Normal will be perpendicular to this. Therefore, if you consider dr's of normal, dr's of given line and dr's of normal, same formula we will get. Instead of cos, we will get sin theta. Formula remains the same. A1, A2, B1, B2 same. A1, A2 is 2, B1, B2 minus 2, C1, C2 2 root lambda divided by root over A1 square, B1 square, C1 square into root over A2 square, B2 square, C2 square. Here sin theta is given in the question. Sin theta he gave 1 by 3. So I will write 1 by 3 here. This is equal to minus 2 plus 2 gets cancelled. We have 2 root lambda. And here what is this? Root upon 9. Therefore which is 3. And this is root over 5 plus lambda. I can also cut to 3. So squaring both sides, cross multiplication, this becomes 4 lambda. If I write lambda on right side, it becomes minus. 4 lambda minus lambda is 3 lambda. Left side 5 is there. This implies what is lambda value? It is 5 by 3. So asked lambda value, what is it? 5 by 3. Fourth option, yes. Question, please see the distance from the point, the distance from this point to the plane, the distance of the point from the plane, that means the distance from this point to this plane measured along the line, this line, x equal to y equal to z. Please read the question properly. The distance of this point from the plane, I shall draw the figure. Say this is the plane, given plane. This is the given plane, yes, whose equation is x minus y plus z equal to 5. And a point is given, no, here this is a given point which is 1 comma minus 5 comma 9. Generally if a point is given, we used to find the perpendicular distance from point to the plane, means we will find this distance, can be found easily. Mod ax1 by1 plus cz1 plus d by root over a square plus b square plus c square. But what he said, distance from this point to this plane, not perpendicular distance, measured along this line, What is this? It is a line. There is x equal to y equal to z is its equation. So its dr's are x by 1, y by 1, z by 1. Of course it is passing through origin also. So the distance from the point to the plane measured along this line. So this one, this is the line. Say it is reaching the plane here. Yes, rough figure. This is the line. So asked the distance from this to this measured along this line. What is the equation of this line? The line's equation is x equal to y equal to z. So for this line, what are the dr's? Dr's of the line are 1 comma 1 comma 1. Yes. So now what I suppose, I have to find this distance, no? I will plot this point, I will denote this point by P. So now I have to find the distance AP. So for that, by taking the line x is equal to y is equal to z. What is this? This is the line, no? The point P is on this line clearly. It is at a distance, some distance from AP. We have to find AP only. I will suppose this is R. So now I am writing the point P, which is on this line at a distance of R from A. This point can be found using parametric equations x1 plus LR, y1 plus MR, z1 plus NR. So therefore we are finding the point P, which is at a distance of R from this. Therefore this is x1, y1, z1, and LMN are DCs of the line. For the line, DRs are known now, so you can write DCs. DCs will be 1 by root 3, 1 by root 3 and 1 by root 3. These are the DCs. That means they are LMN values. And the point is x1, y1, z1. We will put here x1 is what? 1. LR. L is 1 by 3. R is R only. R is to be found. Comma. Y1 is minus 5. MR is R by root 3 only. Z1 is 9. NR again same. What is this? This is point P, which is a point on the given line. But it is also a point on, it also lies on the plane, because we are finding distance from this point to this line along this. That means P lies on this plane also. So this point P lies on plane also. What is the plane equation? X minus y plus z is equal to 5. Therefore it has to satisfy. Substitute. If I write here minus into minus plus 5 minus r by root 3 and z is 9 plus r by root 3 is equals to 5. I can cut minus r by root 3 minus r by root 3. So r by 3 r by root 3 is there. No, what is the number? 9, 14, 15. If I write 15 on right side becomes minus 15, we will have 10. So I will take mod r. What is mod r? It is 10 root 3. So we are finding point at a distance of r from A. On this line, the point can be here or it can be here. If a line is given and a point on the line is given, then there exist two points on the same line at the same distance. So we don't know whether this point which we have taken here, r is what? R is distance. So mod r, that will give us two values. For first value 1 point, second value 1 point. Here we need this anyhow, maybe at that side or this side. The distance magnitude will be same, no? Therefore I took mod. Therefore distance from the given point to the given plane measured along this line, that is AP distance, that is R, is 10 root 3. Yes. Next question. The distance between the line, here a line is given. This is the line. And the plane. And a plane is given. What is the distance between the given line and the plane? So here common sense. Listen Nana. If a plane is given, say this is a plane. And if there is a line can be parallel to this or may not parallel to this. If the line is parallel to this, then you can find the distance between line and plane. You will get unique distance. Here distance is defined, distance between line and plane. If the line is not parallel to this, for example, if line is like this, then distance between the line and plane means there exist infinite values. So unique distance will not exist here. So in this case, distance cannot be defined. So when a line and a plane are given, you can find the distance between line and plane when the line is parallel to plane only. Yes, so in this case only distance will be defined if the line is parallel to the plane. So we are finding distance in this problem. Distance, area, volume, etc. They are independent of systems. If you take vector system, distance remains same. In Cartesian system, same distance. You can use any system. See Nana, this is the line. So what is the line here? The line is of the form vector equation r bar is equal to a bar plus t into b bar. It represents a line passing through the point a bar and parallel to vector b bar. Here a bar is a point, that means this is a point on the line. I will take point here. So it is a point on the line 2, minus 2, 3. I took geometry point. Distance between line and plane is nothing but distance from this to this. If you find this, that will be enough. So how to calculate this distance? I will also take this plane and I will express this in Cartesian system. How to change it into Cartesian system? Very simple. Whenever you want Cartesian system of a vector equation, just put r bar is equal to xi plus yj plus zk and eliminate vectors, unit vectors. You will get an equation in terms of xyz, which will be the Cartesian dot product. So what we will get? X plus 5y plus z equal to 5 or minus 5. So plane equation has come, the point is there, therefore the required distance, the distance between line and plane is nothing but distance from this point to the plane. That can be found simply using mod ax1 by1 cz1 plus d. That means write the point in the plane by root over a square plus b square c square. Yes, here 3 plus 2 5 minus 5 gets cancelled. We have only 10 in the numerator. Mod is there. Divided by what is this? Root 27. Root 27 can be 3 root 3. Therefore this is the distance between given line and plane. Therefore it is third option. Yes.